Hi there, this is Professor Eckhouse, and we talked about factoring quadratics in the last video, and this time we are going to talk about a couple other methods for factoring quadratics that don't involve just simple factoring. All right, so we're going to look at taking square roots and using the quadratic formula, and then we're going to look at a model application modeling projectile motion. So first, let's just start by trying these first three problems. So pause the video and try these three warm-up problems. Okay, so 3 squared is 9. Negative 3 squared is also 9, which means the square root of 9 is either 3 or negative 3, which we often write as plus or minus 3. So we don't have to write so much. Okay, so keep that in mind. So we're going to solve quadratics by taking the square root first. So x squared, I'm going to write this a little bigger, x squared equals 25. So in order to solve a square, we do the inverse operation to solve for x always. So that wasn't very good. We are going to take the square root of both sides. The square root of a square means that we get x. The square root of 25 is plus or minus 5. So there are two answers. And the reason we look at two answers is because when you graph this, you will see there are two places, two answers to this. Okay. All right, so moving on. What if you had a 3 in front? If I took the square root right now, I'd get some irrational square root of 3. So let's try to isolate the x squared before we take the square root. So always isolate the thing you're taking the square root of as best you can before you take the square root. Okay, so taking the square root comes at the very end. So we're going to divide both sides by 3, and we get x squared equals 25 again. So take the square root of both sides now because we have it isolated, and we get x equals plus or minus 5. All right, let's try another one. What would we do first here? We want to isolate the x squared before we take the square root. So I am going to add 32 to both sides, and I get 2x squared equals 32. Now keep going, you want to isolate, so I'm going to say divided by 2 on both sides. And I get x squared equals 32 divided by 2 is 16. Now take the square root, now that we've isolated the x squared, and it's alone, so now we can take the square root. So the square root of x squared is x, the square root of 16 is plus or minus 4. So two answers, plus 4 and minus 4. Okay. Next one, what are we going to do with this? All right, so I'm going to rewrite that. X minus 2 squared equals 64. Well, the square is isolated, right? There's nothing more we can do with this except for to just take the square root of both sides. So this one's a little more complicated to answer because now we have to say, all right, the square root of x minus 2 squared is x minus 2. The square root of 64 is plus or minus 8. All right, so that means x minus 2 could equal 8, or x minus 2 could equal negative 8. So I'm going to add 2 to both sides of each one, two different equations, and I'm going to get two different answers. So I get x equals 10, and I get x equals negative 6. So try it in the original equation. I challenge you to do that, plug it in for the x, and see that you get what it says you should get, okay? All right, so let's move on. So we have two different answers, x equals 10 and x equals negative 6. All right, next one, very similar, so why don't you pause the video and try it. Okay, so we have x plus 5 squared minus 5 equals 4. Okay, so we need to isolate the square, so I'm going to say plus 5 on both sides. And I get x plus 5 squared equals 9. So now I can take the square root of both sides, and I get x plus 5 equals plus or minus 3. All right, so x plus 5 equals 3, and x plus 5 equals negative 3. Either one, because two different answers. So I'm going to subtract 5 from both sides of this first one, and I get x equals -2. Subtract 5 from the second one, and I get x equals -8. So I get -2 and -8. All right, so this time I'm going to work with you to check this. We don't have time for this. All of this, the video would be too long, but let's just check really quick to see. So we've got x is -2 plus 5 squared minus 5 equals 4. So that's my first number, and I also had -8. So I've got -8 plus 5 squared minus 5 equals 4. Okay, so those are my two different solutions that I got, -2 and -8 that I plugged in for x. All right, so I've got -2 plus 5 is 3. 3 squared minus 5 equals 4. So I get 9 minus 5 equals 4. Is that true? Yes, it is. It checks. The next one, -8 plus 5 is -3. -3 squared minus 5 equals 4. 9 minus 5 equals 4. Again, it checks. Okay, sometimes, like I've said before, checking really can help gain understanding of what you just did, because you're basically working it just a different way. All right, so give this one a try. All right, so we've got x minus 3, the whole quantity squared, plus 5 equals 10. I'm going to subtract 5 from both sides. I get x minus 3 squared equals 5. All right, so we're going to take the square root of both sides. I did not give you a perfect square this time because not everything is a perfect square. It's not always going to work out quite so nice. So the way we write this, instead of using a decimal, we want an exact answer. Mathematicians love exact answers. So we're going to say plus or minus the square root of 5 because it's an irrational number, so we're just going to leave it like that. I like these better because you don't have to solve 2, and you can just add 3 to both sides, plus 3, and the way we answer this generally is to say x equals 3 plus or minus the square root of 5. So there's two different answers there, but we get to write them as one. Okay, so there's our answer. All right, give the next one a try. Okay, so we've got 4x minus 5 squared equals 100. We're going to square root both sides because the square is already isolated. So we get 4x minus 5 equals square root of 100 is plus or minus 10. All right, so we're going to have to break it up into two equations now. So I get 4x minus 5 equals 10, and 4x minus 5 equals -10. So I'm going to add 5. Well, let's just work the first whole equation first. 4x minus 5 equals 10. So I'm going to add 5 to both sides, and I get 4x equals 15. Divide both sides by 4, and I get x equals 15 fourths. And that is a fine answer. You can just leave it like that. Now, the other equation, I'm going to add 5 to both sides again, and I get 4x equals -5. Now I divide both sides by 4, and I get x equals -5 fourths. Again, a perfectly fine answer. So you don't have to get decimals or anything, just leave it as a fraction. So those are our two answers. Those are a little harder to check, but you can check them as well. All right, example 8. Let's just stop there. All right, so we've got 3 times 2x plus 2 squared equals 48. So I need to isolate the thing that is squared. So I'm going to divide both sides, the whole thing, by 3. The 3's are going to cancel out over here, and I'm left with 2x plus 2 squared equals 16. Okay, now take the square root of both sides, and I get 2x plus 2 equals plus or minus 4. So again, I'm going to move that over so I have a little more room here. So I need to make two different equations. So I'm going to have 2x plus 2 equals 4, and 2x plus 2 equals -4. So working the first equation, 2x equals 2, divide by 2, x equals 1. Second equation, 2x equals -6, divide by 2, x equals -3. Okay, so there's my two answers, x equals 1 and x equals -3. Okay, using the quadratic formula to solve equations. So when the quadratic is not factorable and you can't find any other way to do it, use the quadratic formula. So for an exact answer, don't simplify. Don't use your calculator. Just leave it with the plus or minus in it and everything. For the decimal answer, use a calculator. Just plug everything in and use your calculator. This is going to give you 1 or 2 real or complex solutions. It could give you 2 answers because of the plus or minus. It could give you 1. All right, so plus or minus means, just like we did up above, there are 2 answers. Either we've got the add answer and we've got the subtract answer. So there's 2 answers. 2 answers. The one with the add and the one with the subtract, just like we did up above. Okay, so the discriminant is the thing under here. It's the part underneath the radical. That's called the discriminant. It helps you to discriminate and decide whether it's going to have more than one answer or not, or if it's going to be real or imaginary. Because if it's negative, you can't take the square root of a negative, so it will actually be a complex number, which we are not covering in here. But just so you know, that's called the discriminant. All right, so use the quadratic formula to solve this equation right here. So we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so a is 3, b is 11, and c is 6. And I would recommend doing that. All right, so x is going to be, and there could be more than one answer here, negative 11 plus or minus the square root of b is 11, so 11 squared is 121, minus 4 times 3 times 6. I'm just plugging things in. Over 2 times a, 2 times 3. All right, so I'm just going to keep going. And I get negative 11 plus or minus the square root of, you can put all that in your calculator if you want, and you get 49 over 6. All right, so 49, square root of 49 is 7. So we get negative 11 plus or minus 7 over 6. So this is a nice simple answer, but we get 2, right? So we get negative 11 plus 7 over 6. And we also get, I'll put them in 2 different colors, negative 11 minus 7 over 6. So you just need to work it out. Negative 11 plus 7 is negative 4 over 6. That's negative 2/3. And then negative 11 minus 7 is negative 18 over 6. That's going to be negative 3. So we get 2 different answers. We get x equals negative 2/3 and it equals negative 3. Ooh. Negative 3. Okay, so those are 2 answers. And you can write x equals twice, or you can just put a comma. All right, so try the same thing here. Pause the video and try to work through it on your own. All right, so I may not work this all out step by step, but I'll just set it up for you. We've got a equals negative 4, b equals negative 21, and c equals negative 5. Lots of negatives there. So let me start a little farther over to the left here. We've got x equals negative b, so that's negative of negative 21, plus or minus the square root of b squared, so negative 21 squared, minus 4 times negative 4 times negative 5, all over 2 times negative 4. So negative 21 squared minus, so double check everything, check all your negatives, and what you're going to get when you work this out on your calculator is you should get negative 1/4, and so x equals negative 1/4, and it equals negative 5. Okay, so use your calculator, practice using your calculator, make sure you get it right. All right, next one, we've got an equation that is not in standard form. So you need to rearrange this. So we're going to subtract 35x and add 15 to both sides. So we get 20x squared minus 35x plus 15 equals 0. So we get a equals 20, b equals negative 35, and c equals 15. Very large numbers. When there's really big numbers like this, you can factor by grouping. It might not factor though, so you might have to use the quadratic formula. And when you do, you're going to plug everything in and you're going to get x equals 1 and x equals 3/4. So I do challenge you to pause the video and see if you get those answers using the quadratic formula. All right, so next is just talking about projectile motion. So notice the shape of that fountain. It looks like parabola, doesn't it? And that's because gravity, when it works as a quadratic. So gravity works on things to make them move through the air in the shape of a quadratic because that's what it does. So there we go. Right? And here's another basketball going towards a hoop. So stop motion photography really does a nice job of showing us the parabolic shape of the movement of something thrown up at any angle. So gravity causes things thrown up at any angle to move in the shape of a parabola. This can be described by our quadratic equation right here. So this equation gets some special letters to make things more obvious. So we call it h of t. So h stands for height at any given time, so height with respect to time. And instead of x, we use t for time. And that's it. We just change some of the letters so that it's more specific to our situation. All right, so I've got a couple of examples here that you'll see like on the homework. So an object is thrown upward at a speed of 137 feet per second by a machine from a height of 5 feet off the ground. The height of the object after t seconds can be found with this equation here, where t is the number of seconds since it got launched. When will the object reach the ground? So first I wanted to show you what this would look like. So if this is t, and this is the height with respect to t, it's going to start at a height of 5 feet. So 5 feet would be right here. So if height is measured in feet, time is going to be measured in seconds. So how do I know that? This is feet, and this is seconds, and this is feet. So that's how I know. So t is in seconds, and h is in feet. All right, so this thing is going to get launched up, and it's going to come back down, and it's going to hit the ground. Okay, so I need to erase that because it's going to stop when it hits the ground. It's not going to go through the ground, hopefully. So it's going to land, and it's going to be right there at the end. Okay, so when will the object reach the ground? When will the object reach the ground? So how high up is it when it reaches the ground? It is at 0, right? So h, where h of t equals 0. When something hits the ground, we're going to call that the height of 0. So in other words, we need to set this whole thing equal to 0 and solve it. All right, so we get negative 16t squared plus 137t plus 5 equals 0. So rather than trying to factor this, just use the quadratic formula and plug it in. Okay, so but I do want to point out some things to you. Check out, this thing starts out 5 feet off the ground, and look at that, there's a 5. And it is moving at 137 feet per second, and look where 137 is. Negative 16 comes from gravity. Gravity. Why negative? It's because it's pulling it downward toward the earth. Up is positive, down is negative. So gravity. So anything that's moving using feet and seconds is going to have a number of negative 16 before the t squared. So this all, you can derive this using calculus. So if you take a calculus class, you'll learn how to derive this. I believe it's in calculus 2. All right, so now we just need to say, all right, negative 16 is a. So a is negative 16. B is 137. C is 5. And you're going to use the x equals negative b plus or minus the square root of b squared minus, oh, I've forgotten it because I'm trying to talk on a video, which is never good, minus 4ac over 2a. So use that, and you're going to find two answers to this. You're going to find, oh, and I changed to x. We're calling it t, so let's keep calling it t. So we find that our two answers are going to be negative 0.036 and so on, and 8.60. So we're supposed to round to 2 decimal places, and I got 8.60. So, is time going to be negative? No, we're talking about over here. We're not talking about back there in negative time. So what is negative time anyway? So we are talking about just the 8.6. So when you get a negative answer with real world situations in time, you can just throw out the negative one and say at 8.6 seconds, this thing is going to hit the ground. Okay, so this is a pretty important formula for real world situations, such as when they launch a SpaceX rocket. Here's an example of figuring out when this thing is going to splash into the ocean. Okay, so h of t, so this should really be h of t. H with respect to t is in this situation. So why is it 4.9 instead of 16? Why is it not 16? Well, it's because now we're talking about meters and seconds. Okay, so this thing launches from, let's see, does it give us a height? Meters above sea level. So it must have started 192 feet above the ground, because that's where the 192 is. So there must be a launch pad 192 feet above the ground. 192. It didn't say that, but from our last problem, we can figure that out. And this thing is going to go up and down and land. And as you can see that over here, you can see the shape in the picture. That's the actual picture of SpaceX launching a rocket. All right, so we've got that A equals negative 4.9, which it always will in these kind of problems when you're dealing in meters. And 226, well, that must have been the speed, the initial speed of the rocket as it took off, meters per second. And this is its height, 192. Right, so you're going to plug all of those into the quadratic formula, and you're going to get that t equals negative 0.83446, and not that one because it's negative. And the other answer you would get is 46.96 seconds. So at 46.96 seconds, it lands in the ocean. It's a very quick flight. All right, that's all I've got. Thanks for watching.